Hi guys, I'm Steve Isaacson. My project is about rainwater collection and integrating buildings with hydroponic systems. So what type of buildings does this include? Residential, commercial, skyscrapers, random storage sheds in your backyard, and McDonald's. Pretty much every building that is out there. Let me introduce and demonstrate the problem. As you can see from the images I just displayed, there's a problem with runoff from buildings. Have you seen this before? How often do you see this? Where? It's pretty much everywhere you go, right? You always see this runoff. So let's look at the big picture of architecture design. One of our main goals, especially in sustainability, is that we integrate into our environment, and we try to do that as perfectly as possible. I would argue that construction techniques we currently have physically separate our cities from the natural environment. I would propose that there's a better way to do this. We can integrate with animals and plants and with the terrain and human needs much better. But the real problem isn't issues in construction or architectural design. The problem is in public perception and with people's economic agendas. I propose that if we integrate modern buildings with new hydroponic system techniques, that it can dramatically reduce water waste. Can you think of any other material that can filter water better than a plant? There are several different water filtration strategies out there, but all of them are very costly and require big wastewater treatment plants or other expensive equipment. But plants do it naturally. It's a basic concept. People need evidence, though, to make a change. We need to come up with several different ideas of interest, also known as discourses. I propose the following research framework. First, we need to research how to grow large quantities of hydroponic gardens in diverse climates. That will help people understand how practical and feasible that hydroponic systems really are. Secondly, we need to research how structures can physically hold the amount of hydroponic gardens and how they can gather the water and show them in designs. Lastly, we need to research tactics that convey to the general population that emphasize the needs for these new structural systems and these new hydroponic systems. Or in other words, we need to listen to the Gentiles and open up to the public to get more ideas how to make hydroponic systems better and improve on them. When an architect designs a building, where does water conservation come into practice? It doesn't. Architecture is designed to repel water. Building code requires that every building have waterproof membranes. Hundreds of billions of gallons of water are wasted throughout all of the US because of these membranes and because we repel water from our designs. They are contaminated and lost due to impervious surface runoff. But there's technology available out there, like these hydroponic systems. But developers and contractors are unaware or unconcerned because of economical reasons. Part of the problem is because there's some states out there and counties that restrict collecting rainwater. And we have to pause for a minute and think about it from their perspective. They're not entirely wrong because they believe that when water falls down, it will run off and run into the groundwater. And all of that water has already been spoken for. It's a thing called water rights. That if we take away from the rain, we're taking away from somebody's crops or somebody else from the river. But they are wrong because we use the water too. And when that water runs off the building, it actually gets more contaminated and can cause a bigger problem. It goes and pollutes other water sources. And then it creates an even bigger problem. It's estimated that $271 billion will be spent in the next 20 years on wastewater treatment plants. We pay taxes too, so it does affect us. Increasing the rainwater collection would increase the amount of potable water and the quality of life for everyone. And that's not even including all the environmental costs out there of saving water for the planet. Did you know that over 50% of our potable water is wasted? Think about when you brush your teeth, when you're showering, flushing the toilet. Most of that water doesn't even get used. It still comes in the same way it goes out. If we show contractors and clients through quantitative research, meaning we gather the statistics up, like I just did for you, I just gave you two important statistics that changed your opinion, that brightened your outlook on it, it would have a good effect. If we showed them a map, now imagine, of all the water that was wasted, they could visualize it, and that would also have a good effect. But imagine if we took these two, statistics and mapping, and we combined them together so that they could visualize and understand what's going on. How effective would that be? Here's an example from a design firm called Lateral Office. They show that is the decline of the caribou population in the Arctic because of ice. Do you see how the caribou can move around through the ice? Do you see the statistical data showing the migration seasons and that the caribou is in trouble? Now, this diagram, it shows how statistical data combined with mapping tells a story, and it's much more effective than the sum of its parts. Combined, it is understood way better. If I show you how much it rains on an area and then how much of that water gets polluted and wasted just as runoff because of our buildings, and I combine that with the statistical data, that will help people see the problem. They will understand that we need to find a solution. And our solution, hydroponics, will save them money. People are generally aware of hydroponic systems. They're also generally aware about rainwater collection, but perhaps they don't see the potential when we combine them together. We need solid case studies, though. They are out there. We have to gather this information. Most of it's already been done, but it's not been brought to the public's attention very well. I believe this is a huge changing factor for architecture. Imagine beautiful buildings covered in green leaves and able to provide food, able to provide clean water, able to provide beauty and integration with our environment. There is some setbacks though. Hydroponic systems do require an initial fee up front. They require somebody to watch and care for the systems, maintenance, and they're living organisms, so they can be unpredictable sometimes. And that is a detraction from why contractors and developers haven't incorporated this already. They don't know that it is more economical to have these systems in place. And as we do this further research, we can improve upon these systems. We can make them better, which will further the design, and I believe the future holds great potential for these hydroponic systems integrated in our buildings. It's just the fact that change is so hard to make. People don't like to make it unless they have solid evidence from years and years and years of experience. So how does this change ever start? Well, it starts from talks like this. It starts from people gathering the facts together and taking a risk that might be worth it in the end. And I believe that through research projects like the Lateral Office, but in our own research here, we can demonstrate to the public that it is more cost effective, better for our environment, and entirely possible. I hope that we can all imagine a world and a future that has skyscrapers and residential houses and commercial buildings that reuse our water that is integrated through natural means, plants. I thank you for your time.